On this computer, it's recording, so we're good. So we're going to be doing chapter 9 binomial theorem. Now I have some choices to make here in terms of presenting this information to you. And I think that the best way to do it is unfortunately the long way. It's by me showing you that that the binomial theorem is actually something that we can use using the skills we learned in the previous section. Now, when we did Pascal, what we did with Pascal formerly was, you guys wanted to always do this here. You didn't want to do it the long way. I didn't want to do it either because I thought that the Pascal definition was kind of cumbersome to do. It felt so artificial. So that was Pascal's triangle. And what's important about this triangle is, let's say we have x plus y to the second. And you were to expand this, right? So you have x times x, x squared, x times y is xy, y times s is xy, y times y is y squared. Everybody understand how I did that? And so this becomes x squared plus 2xy plus y squared. And what I want to emphasize here is this, and this, which is that. Pascal's triangle takes care of the coefficients for you. Not only that, I want you to notice something about the powers here. This is the second power, 1 and 1. And in reality, I should write this like this. This is really 1x squared, y to the 0, plus 2x to the first, y to the first, plus 1x to the 0, y to the second. That's really what it is. We just don't write x to the 0. Okay? Now, if I did this right now I'll do it here on the side, x plus y to the third, well, that's x plus y times x plus y times x plus y. And so you know that this here becomes x squared plus 2xy plus y squared. So you know that. And now we're just going to go ahead and multiply times x plus y. So you got x squared times x, which is x to the third, plus I'll do the x to the second times xy. X squared times x is x to the third. X squared times y is x squared y. Then you have plus 2x squared y plus 2x y squared, right? Then you have plus xy squared plus y to the third. And we begin the process of combining like terms. I'll go ahead and begin with the x squared y. X squared y. So we have that. I'll go ahead and write x to the third plus, looks like it's going to be 3x squared y. Then we have these two. And that adds up also to 3xy squared. And then we just have the y to the third. And if you notice now, what we're interested in is in these coefficients here, which is there. So Pascal's triangle does this automatically for you. Or we can say better, Pascal's sequence. So we say this is the binomial theorem because it arises in the expansion of these binomials. These are binomials. X plus y is a binomial. Well, basically what they're saying is, since we know this pattern, we can develop a rule that's going to help us deal with any amount of these expansions we want. All right, that's what we want. So any questions or concerns? Because I know I'm blabbing away and, okay. No questions? Wonderful. So here's the binomial theorem. I'm going to go ahead and write it out. So binomial theorem. So x plus y to an n power is going to be this here. It's a combination n0, x to the n, plus n1, x to the n minus 1, y, plus n2, x to the n minus 2, y to the second, plus all the way to n, y to the n. Now, what does these things mean? This is a combination. We usually, and in statistical, see this again, NC, I guess I can write R for this. It doesn't matter. This is, we write it usually, this is what this is, NR. This is n factorial divided by n minus r factorial times r factorial. This is a combination. This will take care of our coefficients. What we discovered, quite interesting or quite peculiarly, is that the result of the binomial expansion is counting. It's a way of counting. It's part of the counting rule for combinations, which I was discussing with statistics last class. And we'll try to put everything together without, too much concern about where this is going. So what I want to go ahead and do is I want to go ahead and work on this and build it up. So I think by the time I'm done with this lecture, if you actually go home and try to do this and come back with some questions, you're going to be just fine. But you got to understand what's happening. So 7B on page 134, we have a first set of questions, which I guess are progressive in nature. So we could develop the base skills to using this binomial theorem. And so we have 7-3. 7-3 written that way is a combination of basically 7 objects chosen 3 at a time, where order does not matter. That's what it means. But this will be, remember, and I'll put here, remember that NR means n factorial divided by n minus r factorial times r factorial. So this is going to be 7 factorial divided by, I'll keep it in black pen just to be consistent. 7 factorial divided by 7 minus 3 factorial times 3 factorial. Well, that's 7 factorial times 4 factorial times 3 factorial. Well, that's 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 4 times 3 times 2 times 1 times 3 times 2 times 1. Well, that causes a cancellation of this, 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 and this, this, and this, this, and this. And you have now that you have 7 times 6 times 5 divided by 3 times 2 times 1, which is 7 times 6 times 5 divided by 6, which is 7 times 5, which is 35. So what is this? Well, let's do Pascal's triangle. Once again, we have 1, 1, 1, 1, 2, 1. So this is n equals to 2. This is n equals to 1. This is n equals to 0. 1, 3, 3, 1. 1, 4, 6, 4, 1. 1, 5, 10, 10, 5, 1. 1, 6, 15, 20, 15, 6, 1. 1, 7, 21, 35, 35, 21, 7, 1. Who is this one? Well, this, we got n equals to 3 here, n equals to 4 here, n equals to 5 here, n equals to 6 here, n equals to 7 here. 7, 0, 7, 1, 7, 2, 7, 3, 7, 4, 7, 5, 7, 6, 7, 7. It's this guy. And as a consequence, you can also remember this. N0 is always 1, and N is always 1 for all of them. Right? 6, 0 is 1. 6, 6 is 1. This is what we're doing with this. So we can create this triangle, but we can also use that formula just to specifically pick out the coefficient. Questions? I don't think I can do any better than that. Like, I don't think I can. I think that's it. That's the best I can. I mean, if you have a question, I can answer it, but, and remember, I have to emphasize this, and it's always corny and stuff like that. And we always want to make light of, of hard work or things that are like corny, But effectively, this is what it is when you try to take things seriously, There's always a time for lightheartedness. I mean, there's something to be said about that. But there's a time to work, and I guess this is the time for me to work. So, all right. So find so the next question, number 2 says, it says find the coefficient of x to the third in the following. So here we have 1 plus x to the 5th. Okay. So they want us to find the coefficient of the x to the third term. Now, I should go ahead and write the binomial expansion formula again, and I'm not going to rewrite it. I'm going to go ahead and lasso it and bring it down, which is cool. Just so it's again ready at the notes, so I can discuss it with you guys. Oh, no. Oh, yeah, I got it. No. Yeah. Copy. All right. And I'm going to paste it. Paste. Look at that, like magic, bro. That's so cool. Don't you think it's cool, guys? Are none of your teachers using this? No. I ask you every class. All right, so let's go ahead and write this. So we go, okay, we want the third power here. That's what we want. Okay. And what we notice from the expansion formula is that the third power for whatever we're to use, it depends on what we pick. So let's go ahead and I'm going to write this now generally like this. I'm going to say NR equals x to the n minus r, y to the r. Would that be fair? Like if you come back here and you look at this, like you notice that the power of the y here is 1, which is this guy. And the power of the y here, you see? Now if you look at the original question here, and I'll slide it down here. is you have 1 plus x to the 5th. So the y is kind of like the x here. So what I would do is I would say, okay, if I want the third power here, I'm going to have, for sure, I know n is 5. I know I want a 3 here. I know that this is going to be 1 to the 5 minus 3, x to the third. Because I realize that this is serving the role of the x, and this is serving the role of the y. That's why I put it there. And so if I carry out this computation here, I should be able to figure out the coefficient of the x to the third term. So this is 5 factorial divided by 5 minus 3 factorial times 3 factorial times 1 to the second times x to the third. I'll do another question to make sure everybody's on the same page on this. Okay. Now, you can use your calculator to figure this out. There's a button on your calculator for the factorial stuff. It's called NCR. So if you look for it, it's called NCR. 5 factorial divided by 2 factorial times 3 factorial times 1 times x to the third. Well, let me see if I find it on my calculator here. Let me make it scientific. No, it's not on my calculator right now. Well, yours is more complex. Let's see. Hey, wow, I have this one too. Do I remember where it is? There's turning on, turning on. Okay, come on, computer, hurry up. I press A for calculate. Then I go look here at the thing and I look for not trig. I go to don't go to menu. I would go to menu and I will go to probability. So you go to menu, scroll down to probability, go to combination, press enter, and then it's NCR, and you would put 5, comma, 3, close that parentheses, press enter, and it says 10. Only if you are careful. And so the coefficient is 10. Voila, like magic. So let's try another problem. I'm going to try to pick something difficult. Let's do number 3. And I want to tell you to work on it yourself. But I'm scared of pausing this video. I mean, I can leave it running. It doesn't matter. So it says here on number 3, it says they want you to figure out the x to the 5th, the coefficient of x to the 5th. So coefficient of x to the 5th. In this case, let's put b is 3 minus x to the 8th. Now, if you look up top, you just have to remember that in general, x plus y to the n equals nr x to the n minus r y to the r. Right? So if you want the 5th power here, right, for the x, so this is your x, then your r has to be 5. Does everybody see that? Sometimes it's better to write this with a plus b. You know, if I wrote this a plus b to the n equals nr a to the n minus r b to the r, then you would quickly see that in this case, we know that this is 3 minus x to the 8th equals 8, and you got to figure out the r. So let's leave the r empty. The first one will be 3 to the 8 minus some r that we don't know yet. And then we have negative x to some r. What r would have to be in order for that x to end up being to the 5th power? What r would you pick for this so that this ends up being to the 5th power? 5. It's not a trick question. It's 5. And so there, you do this. And so now you have 3 raised to the 3rd. What's negative x to the 5th power going to come out to? No, no. It's negative x times negative x times negative x times negative x times negative x. Is it going to come out positive or negative? It comes out negative. So you're just going to have negative x to the 5th here. And then what's 8/5 or 8CR going to come out to? You could use a calculator. First of all, you would turn it on. After that, you would press A for calculate. Okay, so let's talk about solving for it. So you'll do it with your calculator. For those of you without the calculator, you would go 8 factorial divided by 8 minus 5 factorial times 5 factorial. And you would go ahead and say this is 8 factorial divided by 3 factorial. You know what? I'll do it here on the side. Right. This comes from the formula. Remember, this comes from n factorial divided by n minus r factorial times r factorial. That's NCR, which we also write as NR. Right? So this is going to come out to 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 8 minus 5 factorial, which is 3 times 2 times 1 times 5 times 4 times 3 times 2 times 1. And then you're going to begin the work of canceling out. And then you realize right now that you have 8 times 7 times 6 divided by 3 times 2 times 1, which is 6. Just cancel this out, and we're left with 56. So this is 56 times 3 to the 3rd times negative x to the 5th. 3 to the 3rd is 27. So now you have 56 times 27 times negative 1. So you have negative 1,512 x to the 5th. And that's your coefficient, if I didn't make a mistake. This was 3B. So let me go ahead and check my my work. I'm pretty sure I'm right, but gotta make sure you guys have good notes. This is chapter 9. Yeah, I'm right. So the coefficient there is negative 1,512. Is that thorough enough for you guys? Because I don't know if I could be any more thorough. I mean, I could just keep on doing examples. Oh, of course you can make this more difficult, can't you? So number 4 pretty much says the following. It says find the coefficient of x to the 6th y to the 8th. And I really would think that you should try this on your own right now in class. So I'm going to go ahead and actually run the risk of having 2 videos, but I'm going to pause this appropriately. Hopefully, I will. And then I'll unpause it to continue. But I'm going to use a mouse instead of my finger. Because when I use my finger, I mess up. So I go here to more. Come on, computer. And I say pause, resume. Okay, so let's do this problem together. So what you need to realize is the way I do this is I always write under it x plus y to the n, and I write nr, I write x to the n minus r, and I write y to the r. I always do that. So now when I do this question and I want to find x to the 6th, y to the 8th, I just write 3x minus 2y like this to the 14. And then you go 14, and then you don't know the r you're going to pick. So now I write here for x, I write 3x, and I put a parentheses in it, and I put 14 minus r. And then I have y, which will be negative 2y, right? Like that. And I put r. And I ask myself, okay, what r would I put in the y there to make it to the 8th? And you can see it's going to be 8. Because 14 minus 8 is 6. So the moment I put 8 here, you see that? Now you have everything.
Wait, but why do you need 8?
Because the question wants you to get the y to the 8th power and the x to the 6th power. Well, 14 minus 8 is 6. You see that? So you have 14C8. So again, you could either do this with the calculator or without the calculator. If you did it with a calculator, you would turn on your calculator. You would press A in your calculator. You would go to menu. You would go to probability. You would go to combination. You would press enter. Then you would put 14, comma, 8, close the parentheses, press enter. You have 3003. So this is 3003. 3x to the 6th power, negative 2y to the 8th power. See that? And so now 3 to the 6th, 3 raised to the 6th power is 729. So it's 3003 times, and I'll go ahead and just write it like this, times 729 x to the 6th. Then you got negative 2 raised to the 8th power. So negative 2 raised to the 8th power. It's going to come out positive. That's 256. And then y raised to the 8th power is y to the 8th. And so now you just multiply all the coefficients, 3003, not the coefficients, all the constants to get your final coefficient. It's going to be probably a huge number. And it is quite a big number. It's almost kind of like worrying a bit, like really they did this to you guys? This is kind of rude. And there we have it. We have 560,431,872. And if we check this, make sure that we're not producing bad notes. 9B. This is number 4C. Yep, that's the answer in the back of the book as well. So it is cumbersome, but you follow the process and you should be able to get the coefficients. Now, the question is, are you clever enough to do the homework and some of the more advanced problems? I hope so. I hope so. So it begins with you just trying to do the questions. So what I want to do, so I won't put this in the video. I'll leave it to you to do in class. Or do you want it to be in the video? In the video. Okay, fair enough. Yes. Oh, well, I didn't write it. Because there. But the coefficient is this.
Wait, Mr. How did you get
3003? Okay, so that comes from, I did it with her calculator because I didn't want to go through the trouble. But it's this. It's 14 factorial divided by 14 minus 8 factorial times 8 factorial. If you did that, you get 3003. Yeah, so if you use your calculator.
It doesn't have it.
Yeah,
Yeah, it does. Look.
That's
Rob?
PBR. I thought it was NCR. That's what I was looking for.
So you put 14 prob C, and then you would put 8. Ta-da! Yours is a little bit different, but yours is the best one, I think, because it's right around, if I remember correctly. Think, Jimmy, think. Let me see if I see it. Right there, right here. So you would put 14 shift to C 8. You see it? Do you see where it was?
I don't get where you get the 8 from.
The 8?
Oh, here, just kidding.
You see it, right?
Yeah.
Okay. Anybody else need help to figuring this out on the calculator? Guys, the key here, and I think I noticed it, is whenever you don't understand something, you ask. But in order to do that, you can't be shy. You can't worry about what people think about you, right? And then you got to be disciplined enough to not allow your mind to meander thinking about trivial things in class. That's your problem. If you ever sit down and observe your thinking, observe your thoughts, they come and go. Some of us spend most of our day not focusing on anything in school, some of us, or not as much as we should. And it all has to do with little voices in your head, whatever they are. They're constantly thinking about a bazillion things, and you can't control them.
You guys, I hear voices. I don't hear voices.
All right, let's do a more advanced question. Well, not advanced, an interesting question. Okay, let me give you time to work on it, and then we'll I'll put it on the board, and then we'll do it together. Let me pause the